So let's get started on our journey to building a 32-bit floating point adder and subtractor. Now we're going to take care of some of the basic mathematics in this video. I am assuming that you do know how to add and subtract positive and negative numbers. Now just in case you're a bit sticky with that, I have added an extra video into the appendix section, so if you're unsure about some basics, then you can go and have a look at that video before you start the course. So we'll start off with the line up here. Now we're going to be adding numbers together. The first question is, how many numbers are we going to add? Well, that's simple. We're going to add two numbers. We'll call one number x and the other number y. So that's us got off to a good and a nice easy start. Now the number x can be a positive x and it can be a negative x. So in order to write the positive and negative numbers, I've put them in a bracket. So within this bracket, this number is a positive x, and within the bracket this is a negative x. And of course we've got a positive y and a negative y. We've also got two functions that we want to perform. We want to perform addition, which is given by this sign here, and the subtraction, which is given by this sign here. Now you'll notice straight away that the sign for the addition is the same sign that we use for a positive number, and the sign for subtraction is the same sign that we use for a negative number. We don't need to use different signs. Now we're also interested in whether the value for x is greater than y, or whether the value for x is less than y, and whether the value for x is equal to y, but we'll cover x is equal to y later on in the course. We're also interested in the absolute value. So the absolute value of a number is written down as this term here. So it's x with the two lines, and the absolute value for y again is written with y with the two lines. So for example, if you had the number minus 5 and we were to find the absolute value of minus 5, that would give us the number 5. So in all cases here, it will just give us the positive value. Now, we're also interested in a couple of properties of the number system. The first is that addition is commutative. That is, if you were to add x plus y, that's the same as y plus x. So for example, 5 plus 7 is 12, and 7 plus 5 is 12. Now, in order for us to do subtraction, we're going to note that whenever we subtract one number from another, it's equivalent to adding on its negation. So for example, x minus y, well that's the same as writing x plus the negative of y. So these are the only properties that we're really interested in terms of our mathematics. Now when we add or subtract two numbers, we're going to have an answer, and that answer is going to have a magnitude, for example 7 or 5, and it's also going to have a sign. It's going to be either positive or negative. So we want to split our working here into these two sections. First of all, we want to look and find the magnitude of the answer, and secondly we want to find the sign of the answer. So we want to have a look at all of the possible combinations of adding and subtracting positive and negative numbers. So we know that the x can have a positive or a negative value, so that's two values for the x. We know that the y can have a positive and negative values, so that's two values for the y. So it means that we can draw out a little truth table. So let's say, for example, we want to add the values of x and y. Now Sx just stands for the sign of x and Sy stands for the sign of y. So let's say we want to add together two positive numbers. We could also add together a negative and a positive, or we could add together a positive and negative, or we could add together a negative and a negative. Now whenever we add together two positive numbers, we get a positive number. So really what we're saying here is we perform an addition. Now the best way to look at this is via examples. So let's say we take the number 7 and the number 5. we could add 7 onto 5, and you'll note here I've put plus 7 in the brackets, which tells us it's a positive number, plus 5 in the brackets, which tells us it's a positive number, and this is the addition sign here. So when we add these together, we're going to get a value of 12. So the final answer here, that is the magnitude of this answer, is a value of 12. We're just going through an addition algorithm. Now if we look at the bottom one here, if we had minus 7 plus minus 5, then that's going to give us a value of minus 12. So you can see here that the magnitude of this answer is the same as the magnitude of that answer. So that is that whenever we have added together two negative numbers, we perform the addition algorithm. But if you were to look at these other examples here, if Sx or Sy was positive and the other one was negative, then for example we could have minus 7 plus the value of our plus 5. So that's minus 7 plus 5, which is minus 2. So what we've actually done here is we've gone through a subtraction algorithm. We've really said 7 minus 5, which gave us the value of 2, and then the sign is computed separately, and we've got a negative value for the sign. So if these signs are different, then we perform a subtraction algorithm. But if the signs are the same, we perform an addition algorithm. Now we could have another 4 possibilities here. We could have again the Sx and the Sy, but instead of performing an addition, we could perform a subtraction. And we could look at the examples here. So let's say for example we had two positive numbers and we subtracted them, then it would just be a case of 7 minus 5. 7 minus 5 is a value of 2, so we just perform that subtraction algorithm. Now again, if both the numbers were negative and we were to subtract, then we would have minus 7 minus 5, which that's equivalent to minus 7 plus 5. Minus 7 plus 5 is a value of minus 2. So again, we've gone through a subtraction algorithm. We've had the 7 and the 5 and we got a value of 2. Now these two here will provide an addition algorithm. So for example, this one here, we could have minus 7 minus plus 5, and that's equivalent to minus 7 minus 5, which is minus 12. So again, we've gone through an addition algorithm to get the value of 12. So that's 8 possible combinations. Now we actually have another 8 combinations, and those 8 combinations are given if we were to swap the value of our Sx and Sy. So you'll notice here in all of the examples we've got our Sx as the larger value. By large I mean a larger magnitude. So all of the 7s are down here and all of the 5s are down here. But we could swap it round the other way round about. We could take all of the 5s over here and take all of the 7s over there. So that would give us another 8 combinations. So in effect we would have 16 possible combinations that we have to take care of. And we have to have an algorithm that ensures that whenever we work through all of these 16 possible combinations, one, we get the right magnitude or the right absolute value for the answer. And 2, we have to make sure we get the right sign for the answer. And the rest of this video is in how to generate such an algorithm. So you'll notice that this here is actually the truth table for an exclusive OR. Now in our 32-bit floating point arithmetic, we know that the first bit tells us the sign of the number. So if the first bit is a 0, the sign is positive, and if the first bit is a 1, then the sign is negative. So in effect we could replace the positives here with a 0, and we could replace the negatives with a 1. So this table here could actually be written as the 0, 0 giving us a 0, or the 1, 0 giving us a value of 1, or the 0, 1 giving a value of 1, or the 1, 1 giving a value of 0. So this here is an exclusive OR. Now this table here is an exclusive NOR. So this is going to give us a way or a method of working out whether we have to add or subtract the numbers, depending on the sign of the x value and the sign of the y value, and whether we're actually adding or subtracting. But we don't need to use both of these, we can actually use just one of them. And the reason why we can use just one is because of this little section here which we talked about at the beginning. If we were to subtract a number, it's the same as adding on the negative. So rather than working with this subtraction table here, which is an exclusive NOR, we can just convert this back into the exclusive OR. So for example, if I was to take, say, just this line here, then we would have a positive and a negative, and we would be subtracting them. So an example of that would be +7 minus -5. Now we've said here that whenever we subtract a number, it's the same as adding on its negative. So we could change this value here from subtraction to addition, and we could find a negation of this -5, which is +5. So it means that this line here is in effect the same as a positive number and a positive number being added together, which is in effect the top line here. So it means that this line here, the third one down in the exclusive OR, would be the same as the top one for the exclusive OR. And the rest of these lines here match up with these lines here as well. You can just work your way through them. So it means that we only really need one truth table here, and that is the exclusive OR, and we can do the subtraction by adding on the negative value. So we've looked at the 8 possible combinations of adding and subtracting two positive and negative numbers. And we've seen that the subtraction of a number is the same as adding on the negative, and that allowed us to take the exclusive NOR table here, and we could implement this here within the exclusive OR. Now we also mentioned that we're going to have to take care of the possibility that Sx is not greater than Sy, but Sx is less than Sy. So if we were to take this 5 column here and put it down here, and we take the 7 column and put it down here, we would have another 8 possible combinations. But again, those 8 combinations, they are going to drop into just 4 combinations, because we know that whenever we add two numbers together, addition is commutative, so x plus y would be the same as y plus x. So whenever we swap these round about, it shouldn't change, it shouldn't affect the final outcome. So it means that the 16 possible combinations that we've got could be catered for with this simple exclusive OR. So we've got a partial answer to the first question. How do we work out the magnitude of the answer? Well, we work out the magnitude of the answer by either adding or subtracting, and we know that we can use this exclusive OR table to tell us whether we add or subtract for all 16 possible combinations. So if we were to say the Sx here and Sy are going to be exclusive OR'd, then the answer would be Sz. So this Sz here is going to tell us whether we have to add or subtract. And we know it's going to work for all 16 possible combinations because we can use the fact that in order to subtract, it's the same as adding the negation. And we also know that when we add the numbers together, it doesn't matter in which order we take them. X plus y would be the same as y plus x. So it means that we would only have this simple exclusive OR function that would tell us whether we're actually going to add or subtract. Now that's all for this video. In the next video, we'll look at the second part of the problem, and that is how to decide whether the result is going to be positive or negative. So thank you for listening. I'll get you on the next video. Goodbye.